specific term in the document. And this enables different features. For example, the clustering I showed you before on the extraction of specific relation. In this case, please consider this the demo. The visual analytics is a demo, but just to show you that if I put the link of this device, the system emphasizes all the text related to these devices, all the sentences, sorry, linked to these devices with the highlighting all the linked elements. You can obviously you can click on specific noun so to navigate the text. So let's imagine the navigation of multiple text, like millions or billions of text. If you want to analyze in depth the specific relation, the system can propose you also more in-depth relation, like in this case, subject, action, object, action of different types. So actions, movement, activities, everything, events. Each sentence has been analyzed and structured in these tribal types of attributes with all the complements. So, and established is mentioned in the infinitive form. So all the inflections are analyzed and managed. In this case, complements is when, object who, but there are different type of complements, as you can see here, object what, and the kind of complements. So in this case, you have all the extractions of entities and relations. In this case, you can go in depth on entities. So products, devices, dates. Please remember, this is a live demo. You can test. Obviously, during the project, we can go in depth on the extraction of different, more specific entity types, measures, organizations, money, events, also generic proper noun. From the geographical point of view, there is extraction of geographic that is mapped to the database geonames.org entity types. And regarding categories, also generic proper noun. This is different color means different categories. Each categories can be associated to a different specific taxonomy, as you see in this case. Finance, media topic is a generic taxonomy we took from iptc.org. That is a taxonomy. So different categories. Thousands categories, 3 levels and sometimes 4 levels, as you saw here. Taxonomy, as you see in this case. Used by a news agency around the topic is a generic taxonomy we took from you can see each sentence is related to a specific category, that is the color, and obviously together with the end user and partner, we can train, or they can train, specific semantic rules to extract more categories in depth, so to customize, further customize the category hardware, for example, for different types of hardware. How everything can be applied, because as I mentioned at the beginning of the demo, the technology is based on a knowledge graph that can be personalized, and the knowledge graph in this case, in English language, is composed by 2 million concepts and 6 million of different type of relations. In this case, bank has a different concepts, different meanings, as you can see here. Red is the verb, so to deposit. If I click on the first, a finance institution that accept deposit in changing, you see there is all the hierarchy in the ontology. And credit union is a type of bank, also World Bank. Everything can be navigated. Like this is the list, but obviously also in this case we can put more details on. And this is the father, so generic concepts. And this is the generic, so United Nations agency is a department, a bureau. If I click on bureau, I can see all the type of bureau below. So this enables the disambiguation algorithm, because as I showed you before, the algorithm extracted the meaning, not only the keywords. So there are different layers, as I showed you. So the tokenization, the keyword, and the grammatical, logical, semantics, and morphological. So the target is to remove ambiguity, so the disambiguate, and to enhance precision in the analysis. And one of the steps of the disambiguation algorithm is to navigate the ontology, so to extract the real meaning. Like a human being while reading a book, if he or she read the first page, perhaps he understands something. If read the 20, 30 page, he can apply reasoning also the first page read previously. And this is the same as in this algorithm. So the target is to remove ambiguity and to give more precision to the end user, to the final reader. In this case, I can show different dimensions. The corpus means all the concepts very often, that can be very often found around the department bureau. So brickwork, inspect, inspection, everything. So let's imagine a multidimensional graph that the algorithm can navigate. So to remove ambiguity, to enhance precision, so that all the tasks after the analysis of the text, of multiple text, let's imagine multiple text analyzed, can be saved in a decision support system. So all this information can be saved in a decision support system. So the end user, the reader, the analyst, the practitioners can start reasoning from a multiple amount of structured information coming from the analyzed unstructured documents. This is what I'd like to show you. Thank you so much. And my previous slides, you can see also my contacts. If you want, you can contact me and we can go further to show you other live demos, specific domain like life science, telecommunications, cyber, and so on. Thank you so much and have a great day.